In this lesson, we are going to learn about the dreaded closures. The Apple definition of a closure is as follows. Closures are self-contained blocks of functionality that can be passed around and used in your code. Now, if you're like me, the first time you see this definition, you're like, wait, what? But you will see this definition all over the internet in tutorials, as if this supposedly explains what closures are. My goal is to do better in this lesson, and that by the end, you will understand closures a little better. And by the way, everything we are going to be going through here is in the official Apple documentation that I will link in the next article, along with some exercises to help you cement this knowledge. Before we get into closures though, we need to take a look at functions some more. And the first thing we need to know is that functions have types. Okay, so we're going to start out with a new playground here. Just going to create a blank playground and say next. And I'm going to call this closures and put this on the desktop. And I'm going to delete that variable there. Now, just like we have talked about variables having types, for instance, var name is of type string and equals Johnny. So this variable has a type. Functions also have types. So let's write out a couple simple math functions. We'll have one for addition and one for multiplication. I'll say func add two numbers, and this is going to take two parameters, both of type int, a of type int and b of type int. And then here in the function body, we're just going to return those two added together. Then we're going to create a second one for multiplication. I'm going to say multiply two numbers. And same thing, two parameters, both of type int, a and b. And then here I'm going to say return a times b, and I forgot the actual return type here, so do your arrow and return an int, and same thing for multiply, arrow and return an int. So if the type of name variable here is string, what is the type of these functions, all right? A function's type is made up of its parameters, and if it has one, its return type, okay? So this right here is more or less its function type. So the function type here is equal to int, and returning an int. And this can be read as a function that has two parameters, both of type int, and that returns a value of type int. And you'll notice that the function type is the same for both of these functions. Both have two int input types and a return of an int type. So now what are we going to do? Let's create a third function called func do math, and we're going to pass into this three parameters. The first two are going to be our integers a and b, but the third one is actually going to be a function type, okay? And I'm going to call this operation. And just like we do with the regular parameters that we've been doing, we give it a name and then a type, okay? So the type for this operation is the function type for these two functions. So I'm going to say input of two ints and returns an int. And then in the body, we say operation, and we pass into it a and b. So we have three parameters, a, b, and then a function type that we are calling operation. Then in the function body, we say operation, and we pass into it these two arguments. So how's this look when we call this function? We say do math, and we can put in our two ints. So I'll say something like 2 and 4. And then for operation, it's expecting a function type of int returning an int, which is exactly what we have up here with our two functions. So we should be able to put in either of these two functions here. So I'm going to say multiply two numbers, and you'll see here multiply two number a colon b colon. And if we run this, you'll see the result over here, 8, because 2 times 4 is 8. We can also swap this out for add to number, And if we run it again, we'll get 6, 2 plus 4. So that is pretty cool. Functions can actually be passed as arguments to other functions, but the types have to match. For example, I couldn't do something like func sum 3 numbers and then have 3 numbers here. We'll say a int, b int, c int, and return an int. And then here say return a plus b plus c. That won't work if we try to pass that here, sum 3 numbers, because the function types don't match. This is not the same as this. All right, so this is obviously a little bit of a contrived example because you would never actually, make these big functions and a separate function to call them both because, these are very simple operations. But this is just to show that functions have types and that you can pass a function as an argument into another function, so long as the types match. Okay, so now that we have introduced this concept of functions being able to pass as arguments into other functions, let's take a look at closures. Swift's closure expressions have a clean, clear style with optimizations that encourage brief, clutter-free syntax in common scenarios. These optimizations include inferring parameter and return value types from context, implicit returns from single expression closures, shorthand argument names, and trailing closure syntax. And we're going to take a look at all of those optimizations here in a bit. So let us start by converting the above functions into closures. We started out writing functions because they are easy to understand. They are easily readable. Closures, on the other hand, if you don't know what you are looking at, are intimidating and harder to read. But by going step by step, you will see how closures are basically functions that are streamlined and passed as an argument. So let's take a look at the closure expression syntax, which we have here. You'll see that they begin and end with curly braces. You have your input parameters inside parentheses and a return type. And then you have the keyword in. And then you have whatever statements, whatever logic you want your closure to perform. So we can actually convert our multiply 2 number and add 2 numbers functions into closures. And it's pretty easy if we just follow the steps, and I'm going to show you those right now. So let's go ahead and I'm going to copy this one here. Let's work with the multiply. So I'm going to copy that and drop it down here. Okay. And the first thing that you may have noticed with the closure expression syntax is that it doesn't have a name or the keyword func. So let's go ahead and delete those two. So that's step 1, remove the func keyword and name. Step 2 is take the curly brace here and put it in the front. Step 3 is adding the in keyword after the return statement if there is one. So right here, then we say in. All right, and that is a closure expression. And we can actually replace where we were calling our function before with this closure expression. So I'm going to cut this and replace when we were calling the function with our closure expression. And now if I run this, we get the same exact result as before. We are returning a times b, which is 2 times 4, and we get 8. All right, so let's go through those steps one more time for the add 2 numbers. So I'm going to copy this and paste it down here. And step 1 is remove the func and name. Step 2 is to take the curly brace here, the opening curly brace, and move it to the front. And then step 3 is to add the in keyword after the return type, if there is one. And then you can take that and place it right here. Very good. And you'll still notice that our types match. Here in our closure expression, we have 2 int parameters and a return of an int type. Now remember that the point of closures is to have clean, clear style with optimizations. Okay, so let's go ahead and put this all on one line here. Very good. Okay, so I'm going to make a comment here. This is after converting function to closure expression. Okay. Now we're going to go through a series of optimizations here. Swift has a lot of neat tricks that we can do to make this even simpler. However, I don't want you to feel like you have to go all the way down to the most simple expression, because at a certain point you start to lose readability, especially if you're new to this kind of stuff. So if you reach a point where you're like, okay, this doesn't make sense to me anymore, go ahead and back it up a step and leave it like that. All right. So the first optimization that we can do is inferring type from context. Okay. We have this doMath function and we have this operation type here, and we know that we are expecting two ints as parameters and returning an int. This means that we don't actually need these type definitions here. It is always possible to infer the parameter types and return types when passing a closure to a function or method as an inline closure expression. So we can actually just get rid of this type. We can get rid of the return and the type, and we can even get rid of these parentheses. Now that being said, you can still make the types explicit if you wish, and doing so is encouraged if it avoids ambiguity for readers of your code, and that includes you. So if it makes more sense for you to have the types in there, go right ahead. Actually, what I wanted to do was I wanted to leave this as is. So I just did some Command Z's there. I'm going to copy this, paste that, and then make the changes here, just so we have a history of the changes. There we go. All right, the next optimization that we can do is implicit returns from single expression closures, okay? So if your closure has only a single return statement, then we can remove the return. So I'm going to copy this, paste that, and this now becomes simply this. The next optimization that we can do is shorthand argument names. Okay, so I'm going to copy this again and paste it here. And now what we can do is Swift automatically provides shorthand argument names to inline closures, which can be used to refer to the values of the closure's arguments by the names $0, $1, $2, etc. Okay, so we have two inputs here, A and B. So these can be represented by, let me get rid of that, and all we need is $0 plus $1. And if you use these shorthand argument names within your closure expression, you can omit the closure's arguments list from its definition, and the number and type of the shorthand argument names will be inferred from the expected function type. The in keyword can also be omitted because the closure expression is made up entirely of its body. All right, so we are getting pretty concise here, aren't we? We've gone from our original function of 3 lines down to 1, 2, 3, 4, 5 characters. So pretty concise. Now there's one last thing that we can do, and this is called a trailing closure. If you need to pass a closure expression to a function as the function's final argument, it can be useful to write it as a trailing closure instead. And so what that looks like, I'm going to copy this again, paste that here, is we can have this be outside of the parentheses. So I'm going to remove that ending parenthesis, put it here after the inputs, and then you can delete the closure name and have it just be like that. And you'll see if we run this again, we are still getting the same result, 6. Alrighty, and that's about as simple as you can make this. Now, going back to that original definition, that a closure is self-contained blocks of functionality that can be passed around and used in your code. I hope that's making a little bit more sense to you now. When we started out here with our first closure expression, we have this chunk of code, this block of functionality, and we are passing it into this doMath function, this doMath operation. And that is passed around and used in our code. So it's pretty cool. Now I want to look at one more example before we finish up here. You've probably, I would bet, used closures before without realizing it. Have you ever done this Google search? Something like how to sort, let me pull the browser over here. How to sort array of names Swift. So let's see here, sort array of objects alphabetically. And you get something like this. Movie array.sorted, curly brace, $0, $1, curly brace. This might start to look familiar to you now, right? So it says here in the closure you pass to sort, compare the properties you want to sort by, okay? So let's go ahead and take a look at this example. I'm gonna say, let names equal, and let's go ahead and continue our Star Wars theme. So I'm gonna say Luke, Han, Leia, and Chewbacca. All right, so let's say we want to sort these names. Well, from our example here, it looks like all we have to do is say names dot sorted by, and curly brace, and we say $0 less than $1. And let's say let sorted is equal to that. And then we'll print out sorted. There we go. All right, let's run this. And sure enough, here we have these nice and sorted now. C before H, before LE, before LU. All right, so those have been sorted for us. So this looks kind of like this, right? So let's go ahead and, just for practice, let's go ahead and transform this closure back into a function going in the reverse direction that we did by taking one of our functions and turning it into a closure expression. All right, so let's go ahead and do that. Okay, so this is where we are right now with this sorted. We are using a trailing closure, okay? So one step back from that was to put the parentheses back in and to add the closure operator name. So you may not know this, but if you looked into the docs, this would be by, okay? So this by here is the same as this operation in the examples we've been doing. And then we need to go ahead and close this with parentheses, okay? So this, we are at this stage. The next step up was to go ahead and put back in our in, right? Oh, my bad. This should be outside of the curly braces. There we go. So now let's jump up to here. Let's go ahead and put back parameter names and the in, okay? So we're going to say, instead of this, we're going to say string 1, and then string 2 in, and then right here, this is string 1, this is string 2, okay? So now we have given back the parameter names, so we're right here. Now let's go ahead and give the return back. So I'm gonna put the return back in here. And then the next step was to give the types back. Okay, so string 1 of type string, string 2 of type string, and we need to put those in parentheses. And then it returns a Boolean. If the first string is greater than the second string, then this closure function will return true, indicating that the first string should appear before the second string in the sorted array. For characters and strings, greater than means appears later in the alphabet than. This means that the letter B is greater than the letter A, and the string Tom is greater than the string Tim. So the final step, which was our first step up here, was to extract this whole closure expression. I'm going to paste it down here, and we're going to do the reverse of our steps. Third step is to add the in. So I'm going to get rid of the in. Second step is to move the curly brace to the beginning. So I'm going to remove that, and that goes right here. And then finally, we need to add a name and the keyword func back. So I'm going to say func sort names. And then we can go ahead and make this look like a function that we're used to. And check it out. So we've gone in reverse from our closure expression that we found here back to a function. And now what we can do is we can actually put this sort names function right here. Sort names. Oh, I think I need playgrounds is a little bit finicky, so I'm going to put it up here. So sort names, and then that would be string 1 colon string 2 colon. And again, if we run this, we should get the same exact results, which we do. All right, so I hope that this has been enlightening for you on how closures work and how they're related to functions and how they are just chunks of functionality that you can pass around, and being able to go from a function down to a closure, and then with this last exercise going from a closure back to a function. I hope that kind of illuminates and makes it more clear how these are constructed and used. All right, so in the next lesson we are going to go over a specific type of closure called a completion handler, and we're going to be using that a lot. All right, so hope you're excited for that, and I'll see you then.